Good evening, friends. In previous class, I have seen the study flow energy equation, how it is applied for boilers, and how the study flow energy equation applied for nozzles. Okay, so in this class, we are going to see how the study flow energy equation applied for turbine, how the study flow energy equation for condenser, and how the study flow energy equation applied for throttling device. Throttling device. Okay. So for all these equations, that's why I told you. First, basically, you note down. You have to keep it in mind this equation. Okay, because this is the steady flow energy equation for open systems. Okay, steady flow energy equation. Q plus M H1. H1 is nothing but U plus PV internal energy plus pressure multiple by volume. Okay, Z1Z plus Vm squared by 2 plus W plus M into H2 plus Z1Z into V2 squared by 2. Okay. So for the conditions for the turbine, so all these things you are going to study in your higher classes in fluid mechanics and hydraulic missions. Also, you are going to study about the turbines, hydraulic turbines and hydraulic pumps. So pumps, what is the difference between pump and a turbine? Okay, pumps which convert mechanical energy to hydral energy. Okay, whereas turbine is a device which converts hydral energy to mechanical energy. Turbine is a device which converts hydraulic energy to mechanical energy. These things, so if you go through the hydraulic emissions lab, you are going to find, and not only that, if your people, most of them you are from Vizag, you are there, you go, if you go to any Simhadri thermal power plants, also there you are going to see what is the turbine, steam turbines, and regarding that gas turbines and some NHPC, okay, National Hydraulic Power Generation. There you find the hydraulic power plants, okay, hydraulic turbines, okay. So regarding gas turbines, these things, turbine is a device which converts mechanical energy to hydraulic energy to mechanical energy, okay. So regarding applying steady flow energy equation for the turbine, applying steady flow energy equation for the turbine, here the conditions are that's why I told you in the beginning. So these are the basic topics, okay. In higher, in next semester and the next year you are going to study everything in detail. Here we are going to study a little bit steady flow energy equation for the turbine, the structure, everything you are going to study in the higher class, okay. So turbine, so for this the condition says Q equals to 0, kinetic energy V2 square minus P1 square by 2 equals to 0, okay. Then what is the condition here? The Q is becomes 0, okay. V1 V2 becomes 0, Z1 Z2 are neglected, okay. So why? Because the quantity of means the mass flow of the fluid and is same in the entire system, okay. So not only that, the elevations are not considered here, okay. So here if you apply this one, M1 H1 is equal to, so W plus M into H2, these three are vanishes. Then what you get? M into H1 equal to W plus M H2. Okay, M, if you take H2 here from here, M into H1 minus H2 is equal to W. This is the condition for steady flow energy equation for turbine. Okay, turbine. So here the fluid enters into the turbine and leaves. This is the system boundary. Okay, so these topics, fluid mechanics and hydraulic machines, is also important, very important subject for your examination point of view is concerned. So why? Because these are the technical subjects. At the same time, you have some practical approach. Unless regarding metallurgy and material science, also it is a theoretical subject. There you must have some theoretical, some practical oriented. Okay. So likewise, for this applied mechanics, applied thermodynamics, just go through the basics. What is a turbine and what is a condenser? Condenser is also used in boilers, where because the water is converted to steam. Steam, again the steam, some part of the steam again converted to water. Okay. So condenser, the conditions for the condenser is the work is 0, heat is considered as negative by heat, some heat is rejected. Okay. The rejected heat can be denoted as negative. So this condenser, what is condenser, what are the importance of condenser, what are the structure of condenser, everything you are going to study in the higher class. So don't confuse about the condenser structure, don't concentrate on the condenser structure. Here we are applying steady flow energy equation for condenser. This condenser structure, this entire structure you are going to study in the higher class, okay. So applying this for the energy equation, steady flow energy equation, okay. So instead of Q, you will replace it as minus Q and mass into H1 plus Z1Z plus V1 square by 2, okay. So all these things will be vanishes, okay. Why? Because these energies Z1, Z2 and this V1, V2 are neglected. So altogether what you are going to get, minus Q is equal to M1 plus H1 is equal to M H2, okay. So if you take H1 from this to this side, M into H1 minus H2 is equal to, if you take Q to this side and H2 to this side, okay. Or what you are going to get, M into H1 minus H2 is equal to Q. So Q is equal to M into H2 minus H1. So these are the conditions for the turbine and conditions for the condenser, okay. So with this you almost condensed, you almost finished the what is, you have seen what is the steady flow energy equation. Steady flow energy equation applied for flow process means open system where mass and energy transaction takes place. We are not applying for closed system, non-flow process, okay. There the cyclic process under constant volume, under constant pressure, under constant temperature, under adiabatic, there we go such process, okay. For non-flow, for flow process open system, we are considering this steady flow energy equation, and in that we are applying certain conditions, with certain conditions and deriving some equations, okay. So next one is throttling device. The name itself is throat. So head, this is throat, where it, body parts is almost shrink, okay. So if your throat means, imagine this one. So this part is called throat, okay, where the passage of fluid is restricted, where the passage of fluid is completely restricted. Even though the flow passage is at high pressure or at high velocity, at this part of the throat, the mass of the fluid is completely restricted. The mass of the fluid is completely restricted, okay. So what are these parameters? So what is throttling device? What are the applications of throttling device? All these things we are going to study in the coming classes, okay. So for this class, applying steady flow general equation, steady flow energy equation applies for throttling device, where here Q is 0 and W is 0, given V2 are very small and can be neglected, okay. So applying for general equation, Q plus M into H1 plus Z1Z plus V1 squared by 2 is equal to W plus M into H2 plus Z1Z2 plus V2 squared by 2, okay. Here the parameters considered as heat 0, okay. W becomes 0, heat, this part is 0, this part is 0, okay. Z1 and V1 squared plus V2 squared, V1 squared by 2, V2 squared by 2 is 0. So what are the parameters remaining? M1 and M1H1 and M2H2, okay. If M is taken as same mass, if mass is kept constant, here H1 is equal to H2, means enthalpy before throttling is equal to enthalpy after throttling. Enthalpy before throttling is equal to enthalpy after throttling. Only thing you are going to consider in condenser, you are going to, instead of Q, you place it as negative Q, okay. Likewise in what are the in compressor, another is where so I already told you in the previous class, heat done by the system, heat entry. So in previous class I have given you one small concept, okay. So suppose heat entering from the surroundings into the system. You have taken one parameter. So regarding heat and work are the parameters are means opposite. Okay, heat from the surroundings entering into the system is taken as positive, or okay, if heat entering from the system, not don't be confused. So for heat and work, if it is work, the sign will be different. If it is heat, the sign will be different. Okay, so the parameters are exactly opposite to each other. So read the problem carefully. Heat entering from the surroundings to the system, heat leaving from the system to the surroundings, work entering from the surroundings to the system, or work leaving from the system to the surroundings. So you have to take the signs very carefully. That's why here heat is rejected from the system. Okay, heat will be rejected from the system. You have taken it as negative Q. Okay, heat rejected from the system is taken as negative. Okay, so thereby instead of Q we place this like this. Okay, with that we almost seen that study flow energy equation applied for boiler. Next one nozzle. Third one is turbine. Fourth one is condenser. Fifth one is throttling device. Okay, so some compressor also there. No need to follow that. Compressor also small topic is there. So with this, we almost find that applying the static flow energy equation for different equations. Why? Because if at all a problem comes, suppose applying, so if enthalpy, so find the heat transfer in a condenser. So if the enthalpy, initial enthalpy and final enthalpy and mass is given, you have to supposed to apply this equation. So what is the work done in a turbine? If enthalpies are given, so you are supposed to apply this equation. Okay. Likewise, so the initial enthalpy, throttling device, what is the enthalpy? One enthalpy is given. Enthalpy before throttling is equal to enthalpy after the throttling is equal to H1 is equal to H2. Okay, these are the important bits. So regarding boiler, regarding nozzle, where they solve some equations. So the how to recollect and how to memorize, that is up to you, because the preparation differs from person to person and IQ differs from person to person. If at all a question comes, try to remember this equation, because if you remember this equation and then if you know the conditions parameters, then you can apply any equation. Okay, if you know this general equation and if you know the basic conditions, then you can apply to anyone, whether it is boiler or nozzle or turbine or condenser, throttling device, everything, almost everything you are going to apply. Okay, so be prepared carefully. So don't waste time. The mids are coming. The mid examinations are almost by the end of this month. So I am going to provide you material. Don't be panic. Everything will be ready within few days. Try to be patient. The material will be provided to you. So regarding metallurgy and material science and this applied mechanics, applied thermodynamics first unit, I am giving 10 questions unit wise. So go through these questions and prepare carefully for your mid exams. Okay, so you are supposed to submit assignments also. So within the, I am giving you a specified time. Within the specified time, submit the assignments also. Thank you.